Thank you, Team New Zealand. There are a few spots available here if you want them. Yeah. All right. So you actually now had a presentation from a Kiwi talking about Norwegian research. Now you'll hear a Swede talk about New Zealand research. Yes. I realize now after a few days I should just have worn a t-shirt saying we don't have salmon lice in New Zealand. But yeah, no, so I'm here to talk about shellfish. I'm here to talk about low trophic aquaculture. And I'm presenting research on behalf of my very talented colleagues. And I'll present how we are trying to use selective breeding to prepare and manage the increasing challenges we see from climate change, so with a particular focus on warming waters. So this is a complex slide. I'll only highlight a few items on here. So I'm from the Cawthron Institute. We are the oldest, largest independent research organization in New Zealand, and we only do marine and freshwater research. We're a charitable trust. We try to do science for good. We want to be here to help. And if you only want to focus on the big blobs in the middle, you see that we work on climate change, we work on the aquatic environment, freshwater environment, we work on seafood, we work on seafood safety. We absolutely work on algae, like Phil mentioned, trying to realize the real potential of algae. And then we also do a lot of work in supporting resilient communities in the Pacific. So how we do this, how do we help the industry, the aquaculture industry? Well, we are doing mission-driven research towards a resilient future aquaculture industry. We're helping the current one. And a lot of that work is going on at our amazing aquaculture facility north of Nelson on the South Island of New Zealand. We have 20 hectares of aquatic fun where we do a lot of work on micro and macroalgae, shellfish. We have a finfish facility. We're co-localized with an oyster industry here, Moana. We have Marlborough oysters here behind the blue. And we have Spad and Zed, which is a company making baby mussels using our technology. So we are co-localized with industry, which makes it really easy for us to rapidly communicate, to understand their needs, and we can respond relatively fast to what they need help with. This is basically 20 hectares of making babies on demand. So if you look at the aquaculture industry in New Zealand, compared to the Norwegian one, it's absolutely much smaller. We farm 3 different species. Our endemic green shell mussel, where we produce almost 100,000 tons, which is a big pile of mussels on any scale. We farm Chinook salmon. Compared to Norway, this is not a lot. We produce 15,000 tons. That's about 1% of the Norwegian production. And we also farm the Pacific oyster. We farm all around the country with a few hotspots around Auckland and the Coromandel Peninsula up on the North Island. And then the majority of the production is here in the Marlborough Sounds in the south, which is really close to where we are based in Nelson. And we see that in the future we will likely move some of this further south due to climate change, due to presence of much cooler conditions down here, particularly for the salmon, where we want to go offshore as well. This is a horrible slide, right? This is a slide summarizing our aquaculture research at Cawthron. And the size of the blob indicates how much work, how many projects we have in that space. So you don't need to write this down in any way. I just want to highlight that we do a lot of work on shellfish. We do a lot of work on aquatic health, biosecurity, new farming technologies, seafood safety, and we also do work on finfish climate change adaptation, which is a topic for another talk. So one way to reach the goal set out by the New Zealand government to make this industry 4 or 5 times bigger by 2035 involves species diversification. So in addition to the green shell mussel and the oysters, we're currently looking at domesticating our paua, our New Zealand abalone, our scallops, the New Zealand geoduck, a couple of clams, the ribbed mussel, and also our New Zealand flat oyster. In addition to that, we have other institutes in New Zealand looking at domesticating native fish in New Zealand, snapper, blue cod, trevally, butterfish. We have successfully managed to domesticate our yellow-tailed kingfish, and there are companies now scaling up that production in New Zealand. So that's very encouraging. Now, this is really why I'm here. I'm here to talk about all the challenges we are seeing with the rapid changes in climate. And this is something that's certainly not unique to New Zealand. We see this all over the place. We have issues with rapidly elevated surface temperatures. We have issues with runoffs from poorly managed forestries. We have issues with lower salinity in coastal water because of a higher frequency of rainfall. We have issues with changes in the phytoplankton composition. We have invasive species coming in to prey on what we farm. The list of challenges is significant, and I'm going to talk about how we are trying to use selective breeding to at least adapt to some of these changes to make our industry a little bit more robust. So this is a slide indicating a range of our different farming sites and the fluctuation in temperature over the last 40 years. And you can see as you move to the right, you see a lot of red. Each red line indicates a heat wave event. And you can see that in the last couple of years, every single farming site in New Zealand have experienced heat waves. And whenever there's a heat wave, there is stress, there is loss of life, and it's just generally a massive headache for everyone involved. So how do we deal with this? Yes. So we're trying to develop hatchery-based technology to at least manage some of these problems. Instead of only breeding for growth or shape or taste, which is what you normally would breed for, we are now also looking at resilience traits. And we are also developing new aquaculture technologies that allows us to technically deal with some of these challenges. For the greenshell mussel, this means that we have domesticated the native greenshell mussel, and this was done a fair while ago, to be honest. Initially, this industry was only based on collection of wild spat, washed up around 90 Mile Beach, Kaitaia at the top of the North Island. You could also catch spat by lowering spat catching lines in certain locations. Now, we have solved how to make babies on demand, actually not that hard, and we now develop different methods for conditioning, spawning, and selectively breeding for a much faster growing product that is mature much faster than the wild spat and also is superior in terms of quality. And now we are trying to make these mussels thermotolerant. And if you look here, what you do, you collect your mussels in the wild, you make mommy and daddy mussel happy. This is actually quite easy, just a bit of cold and warm water. They will happily make babies. You seed them onto ropes, you let them mature, you analyze the phenotype, you take the best ones, you rinse and repeat, and that's how you carry on to generate a superior breeded mussel. So when we are breeding for thermotolerance, it means we have to expose our mussels to elevated temperatures. So our experiments is like this. We keep a certain number of mussels. We slowly increase the temperature. These mussels really enjoy it when it's less than 20 degrees. They can tolerate a few more. That's fine. Slowly ramp up the temperatures, and then we keep it at 26. And then we keep it at 26 until every single mussel is dead. And that sounds horrible, right? I get that. The thing is, if we don't really push them, they will never adapt or change. And if we do this at a lower temperature, the experiment will take forever. If we do it at a higher temperature, they will all fall over within a couple of hours. So 26 works well for this because we want to see differences in tolerance between the families. So the image to the right shows you how well the different mussel families are tolerating this heat. And then we choose members of the most tolerant one, and we make new babies, and we repeat. And we've done 4 of these trials. We have 2 generations going. The challenge with these type of studies is that you need generations, and a generation takes time. There is no way you can speed that up. And we see that this is actually something they inherit. Now, we don't fully know whether this is changes in their genome or whether this is transgeneral plasticity, where they just adapt to what the parents were exposed to. It could be both. For oysters, we have developed very efficient rearing tanks. We call them cuddle tanks that allows us to farm baby oysters at really, really high densities. We've induced triploidy, meaning they have 3 sets of chromosomes that makes them sterile, and they grow much faster. They focus on growth. These are naturally thermotolerant. We managed to breed them resistant to the oyster herpes virus, and we are now trying to breed them to tolerate lower salinity, because these guys are sensitive to lowered salinity. Seaweed, Phil talked about that. We are a few years behind everyone else in this space. We want to learn, we want to see what works here, what doesn't work here. We have 1,500 different species in New Zealand waters. We probably won't farm Saccharina latissima, right? So we need to find the seaweed that makes most sense from a commercial perspective in New Zealand. We need to find a seaweed where we have not so much competition, which is superior. We need a point of difference. So we're developing hatcheries for a range of different species. We're doing IMTA work, and in the future we will do selective breeding for a superior seaweed product too. So focus is on low trophic. That doesn't mean we're not doing this on finfish. So we are doing this on finfish. We have a climate-adapted finfish program where we look at our Chinook salmon, we look at our native snapper together with what was previously known as plant and food. And if you take a look at the impacts of our research, basically, this gives us an understanding of how to increase the resilience in our low trophic species. And at the end of the day, our focus is to develop a sustainable aquaculture industry in the face of rapid global change. And if you think that this is something that could be interesting to what you guys are doing, we have a very talented team doing selective breeding. They do breeding services. They are not only smart, they are absolutely stunning to look at. So there's a lot of stuff we do. And we've done this for actually quite a long time. Making babies, closing life cycles is our bread and butter at Cawthron. So just contact me if you want to discuss how we potentially could help out. And that's it. Thank you.
Thank you for the nice presentation. I think we have 2 minutes open for questions from your chairing committee. Okay, I have a question for you. It's a quick question. So I saw that you collect the parents' mussels from wild population, right?
Yeah.
Do you collect them from several stations? For instance, if you just collect them from one station, you might get the mussels that from one family or just a couple of families.
Ideally, we want to collect from many different locations. That would give us the best data set, just like you suggest. Yeah. We have brood stock in our lab, and we collect at certain spot. But the wider the variety of your starting material, the better the outcome of the experiments. Absolutely.
Yeah. Yeah. Yes. Thank you.
Does this work with other species beyond shellfish? Could you apply it to salmon, for example?
Yeah, no, we have that project is ongoing. It's called Climate Adapted Finfish. It's in one of our bigger MV programs. So we are absolutely seeing positive effects on salmon too. So and I guess that would be of interest to some of the Norwegians, I guess. Yeah.
Yes, thank you.